Well, good morning, good afternoon, or good evening, depending on what time of day it is that you're watching this. And this lesson here, we're going to go over how to find the volume by a method called cylindrical shells. Okay, so I'm going to start off here by first doing this problem here. We're going to find the volume of the solid form by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis. Okay, so we're going to use the disk washer method to do this. And then I'm going to show you the cylindrical shells, or the shell method, which makes it a lot easier. Okay, so we've got y equals x squared plus 1, would just be a parabola about like that. Let's see if I can make that a little nicer. Parabola does something like that. Not much nicer, but we'll go with it. Okay, and then y equals 0 is the x-axis, x equals 0, and x equals 1. You know what? I'm going to do this again and try to make it more like that. Okay, so y equals 0 and x equals 0 are the x and y axes. Right? It's going to be that, and then the line x equals 1 should be something like that. So we've got the region bounded by this right here. So I'm going to, highlight it here. We're going to be taking this region right here and revolving it about the y-axis. So we're going to go about the y-axis. So far we've got the disk washer method. So we're going to have to go with that here. In the disk washer method, if you go about a vertical axis of revolution, you got to do everything in terms of y. So the y equals x squared plus 1, I'm going to solve that for x in terms of y. I'd subtract 1, take the square root, and x would be the square root of y minus 1. Don't have to worry about plus or minus square root because we're above the x-axis, so all the y's are to the right of the y-axis, so all the y's are positive. Okay. So now we've got to figure out this point of intersection right here. Well, where do these two functions intersect? Well, I know it's when x is 1. If I plug 1 in here, that's when y is 2. Okay. So in terms of y, we're going to go from 0 to 2. But I'm noticing something here from 0 to here, we're flush to the axis of revolution, and then we're not. So I also got to figure out what's this point right here. And this point right here would be the y-intercept of this. So this is going to be 1, 1. So from 0 to 1, we're flush to the axis of revolution, and then from 1 to 2, we're not. So we're going to have to set up two separate intervals. First, we're going to integrate from 0 to 1. And all we have to do, it's going to be pi, right? Because we're going to have circles that have a radius of this line right here, and then they're going to go around like that. And this is actually, this part right here is just going to be a cylinder. Right, it's going to be a solid cylinder with a radius of 1. So I know the area of a solid figure is the area of the base times the height. So this is just going to be pi times 1 squared times 1. This should just turn out to be pi. We could do it with calculus. With calculus, we would take 1 and we'd square it and integrate that with respect to x. Right. Now the rest of the way, we're going to have the big circles. Maybe I'll keep these black. We get all the way here. We're going to have those big circles. So I'm going to do pi times integral from 1 to 2. But for the rest of this, I'm going to have my big circles minus the little circles. It's going to be hollowed out. And we're going to do this with respect to x. So the big circles still have a radius of 1. But now these little circles, which would be just circles that go from there to there, they go through and hollow this out. So I've got to find what's the length of one of these little radii. Well, they're just whatever x is here minus x here. And here, when we're on this curve, x is the square root of y minus 1. Here is x 0. So the radii of the blue circles is just the square root of y minus 1. Okay. So now we do this. I integrate 1 with respect to x, and I get x. I do it from 0 to 1. Plug 1 in there, I just get pi. Just like I figured. It's a solid cylinder with a radius of 1. The height of 1, its volume is going to be pi. But now for this other part, we got pi plus pi times the integral from 1 to 2. Here, I'm going to get 1 minus, when I square this, I'm going to get y minus 1. So this makes that positive 1, plus 1 would be 2 minus y. So I integrate that, and I get 2y minus 1/2 y. And I do that from 1 to 2. So I've got the pi, which was the bottom half of it, plus pi times. Put 2 in there, and I get 4 minus 2 times 1/2 would be 1. And then minus, put 1 in there, I'm going to get 2 minus 1/2. So let's see, I got pi plus pi times. 4 minus 1 is going to be 3, minus 2 is going to be 1. Let's see, that's going to be plus 1. It should have been, let's try seeing this, 3. This will be 3 minus 2 is 1, and that's going to be plus 1/2, so it's going to be 1.5 or 3/2. Let me think about this. No, it's something seeming weird, and I did it again, you guys. It's a good thing I felt like something was weird here. When I integrate 2, I get 2y, and then minus, this should be y squared over 2. So this right here should be 1/2 y squared. So then I plug 2 in here. 2 times 2 is 4. Then minus, plug 2 in here, I get 4 times 1/2. This should have been a 2. Okay. So now I get 4 minus 2 is 2, minus 2 is 0, plus 1/2 is 1/2. And 1/2 of pi plus pi would be 1.5 pi, or 3 pi over 2. Okay, now, you guys, a lot of times, if you make a careless mistake, you should get a feeling that something happened. Like when I got here before and I had the 4 minus 1 minus 2 plus 1/2, I was getting 1.5 pi. And I thought to myself, there's no way this little bit right here could have more volume than this part. So I knew something was wrong, and I looked back, and sure enough, I just had that careless mistake there. So watch for those kind of things when you're doing it too. Let number sense help you out. Okay, so this one here, to do the disc washer, we had to break it into 2 regions, and we wound up that the area was 3 pi over 2 cubic units. Okay, in this lesson, we're going to go over this thing called the shell method. We're going to find the volume using cylindrical shells. And the nice thing about this now is when you do it about a vertical axis of revolution, you do everything in terms of x. You do 2 pi times the integral from where x starts and stops times p of x, or integral from a to b of p of x times h of x, where p of x is the distance from any point in your region to the axis of revolution, and h of x is the height of the region, or how far it is from the top to the bottom. Okay. If it's a horizontal axis of revolution, everything's the same, but you do it in terms of y. So now what's so nice about this is a problem like this one we just did, right, was a vertical axis of revolution. We can do it in terms of x. We don't have to convert to y. I would only use the shell method in terms of y if they already gave me everything in terms of y. Okay, so let's try this exact problem again, but now using the shell method. Oh, and look at this, a little meme with some encouragement here. Right? I never lose. Either I win or I learn. Guys, that's true. That's so true. Especially in math here too. When you do a problem, you never lose. Either you get the problem right, or you learn how to get the problem right, or you learn how not to make mistakes. Okay? So the more you practice, the better you're going to be. Okay? Now, if we do this problem again, maybe I'll just, for illustrative purposes here, I'm going to sketch our region again. we had this parabola, something like this, with a line x equals 1, and we were taking this region right here and revolving it about the y-axis. Right, we were going about the y-axis. So if I want to use the shell method, I can do it in terms of x because it's a vertical axis of revolution. So the shell method tells me to take 2 pi times the integral. Now in terms of x, we started at 0 and went to 1, so 0 to 1. And now if I pick a point in here, any point in this region, my p of x is just how far it is from that point to the y-axis. The y-axis is my axis of revolution. So that distance is just going to be whatever x is. It's just going to be x. And it's always that way if you're going about the y-axis. Okay. So think about it. Let's say right here, if we're right on this line, x is 1, the distance from here to here is 1. Now let's say right here, x was 3/4, then the distance from here to here is 3/4. So it's just whatever x is. And then the height of the region is just going to be whatever it would be if I drew a line here. It's just whatever y is here minus y here. Well, up here, y is x squared plus 1. Down here, it's 0. So it's x squared plus 1. And now notice, with the shell method, we're doing 2 pi and not pi. Because we're actually working with the circumference of a circle. Right? When we pick some point in here, and we go about the y-axis, we're making some circle that goes like that, we're finding the circumference of that circle. The circumference of a circle is 2 pi times the radius. And in this case, the radius is just whatever x is. Then the reason why we got to put the height in there is because we're really going from here all the way down to here, right? We're finding this circumference of this cylinder. Right? And then when we integrate from 0 to 1, that finds all the cylinders in here, the circumference of all these cylinders, and then adds all the circumferences together from here to here and gives us the volume, the solid volume of this figure. Okay? So with the disc washer, we're working off the area of a circle. With the shell method, we're working off the circumference of a circle. All right, so now I go ahead, I distribute the x through here, and I get x cubed plus x, right, with respect to x. So now we can integrate that. So let's see, we got 2 pi times antiderivative of x cubed with respect to x would be x to the 4th over 4, or 1/4 x to the 4th, plus this is going to be x squared over 2, 1/2 x squared, and we do it from 0 to 1. So we've got 2 pi times, plug 1 in there, we get 1/4 plus 1/2. Plug 0 in there, we get 0. 1/4 plus 1/2 would be 1/4 plus 2/4 would be 3/4. Times 2 would be 6/4. Reduce it, and we get 3/2, or 3 pi over 2, which, my friends, is deja vu all over again. That's what we got doing the disc washer method. Right? And we knew we should get the exact same answer. If I got a different answer, I knew something was wrong. To me, this is nicer because we didn't have to worry about breaking it down to the 2 regions. That's the beauty of the shell method. You don't have to break it down like that. Also, we didn't have to convert to y. In this problem, it was easy to convert to y, but sometimes it'd be harder. All right, let's get some more practice doing this. Let's do this right here. Let's find the volume of the solid formed by revolving the region bounded by the graphs of y equals 1 over x, y equals 0, x equals 1, and x equals 2. First we'll do about the x-axis and then the y-axis. All right, so again, let's see what this region looks like. Let's sketch a little graph. Now I know 1 over x squared just looks like this and like this. All right, y equals 0 is the x-axis. X equals 1 would be a vertical line right there. X equals 2 would be about a vertical line right there. X equals 1, x equals 2. Boy, I probably could have drawn a straighter line, huh? Something like that. Like that. I'm going to go ahead and erase these things out. And then my curve, I'll do it in black. The 1 over x comes around and goes like that. Let's see. All right, I'm going to snap a picture of that because I want 2 of them. Okay. Let's see. To the image. Take a picture of this. Man, I can't get away from those lines. Let's try it, mixing it up a little bit. Go this way. Try it one more time. I don't like those little lines. I wish I knew what I was doing to get those in there. I'm going to hit them again. All right, I'm just going to live with them this time. So I'm going to pull this down here. All right, so our region is this region right here. Okay, that's our region. We're going to revolve that. First, we'll revolve it about the x-axis. Okay, so we go about the x-axis. All right, even though we're doing the shell method, I think I'm going to stick with the disc washer here, right? You will never be told to use this method or that method to find it. You could do either method. So if it's a horizontal axis of revolution, I personally prefer to stick with the disc washer. Right, so this would be pi times integral. In terms of x, we're going from 1 to 2. We're flush to the axis of revolution. So all we really got to know is what's the radius of our circles, which would come around like that. Right, we're going to have circles that go like that, down to there, that make this shape there. So the radius of one of those circles is just whatever y is here to y is there. And here y is just 1 over x. So the radius of my circle is 1 over x. The area of a circle is pi times the radius squared. So I do that with respect to x. So I integrate this. Well, let's square it first. I get 1 over x squared, which would be x to the negative 2. Okay, so integrate that, and I get x to the negative 1 over negative 1, or negative 1 over x. And I do it from 1 to 2. So I've got pi times, plug 2 in there, I get negative 1/2, minus, plug in 1, and I get negative 1. So this makes positive 1 minus 1/2 would be 1/2 times pi would be pi over 2. Right, so it would be pi over 2 cubic units. All right, now we want to do it about the y-axis. So let's do that here. And I'm just going to accept the fact that this bothers me, that those little lines went in there, but I'm going to live with it. And now we're going to revolve this about the y-axis. Up here we did part 1 about the x-axis. Okay, so if we go about the y-axis, and again we're taking this region right here, about the y-axis. Okay, here's the beauty of the shell method. It's a vertical axis of revolution, so we keep it in terms of x. And we do 2 pi, because we're going to be working with the circumference of circles. We're still going from 1 to 2. And now, any point in this region, the distance from that point to the y-axis is just whatever x is. Right? If I'm right here, the distance from 2 to the y-axis is 2. The distance from 1 to the y-axis is 1. Anything in between is just what that x is. And if I draw lines in here, the length of one of those lines is just 1 over x. Look at that. And this is pretty darn nice. That just turns out to be 1. The antiderivative of 1 with respect to x is x, and we do it from 1 to 2. All right, if we had to do the disk washer on this, we'd have to break it up into 2 regions. It would be a lot more work. This is very simple. So it's 2 pi times, plug 2 in there, we get 2, minus plug in 1, we get 1. So we get 2 minus 1 is 1, times pi, we get 2 pi cubic units. There's our volume. Okay, shell method is very nice for vertical axis of revolution. All right, here's one we'll do 3 times. So it's going to be close to the same looking thing as well, because instead of 1 over x, we got 1 over x squared. So if I just sketch this here, one over x, just like, or 1 over x squared, just like 1 over x. It's just a curve that comes like this, but then it also goes over here. It just doesn't go below. Then we want y equals 0, which is the x-axis. All right, we want x equals 1 and x equals 4. So x equals 1, maybe we'll say is right here. X equals 4 is right here. So we got x equals 1, x equals 4, y equals 0, and y equals 1 over x squared. Those regions, or those functions, all bound this region right here. So that's what we want to find. What did I do there? We want to find the volume. First, when we take this region and revolve it about the x-axis, we're going to do it about the y-axis, and then about the line x equals 4. Okay. So let's see here. I'm going to try to have a gentle touch. I'm going to pause this just in case it doesn't, and I'm going to take pictures of this. All right, so first off, we're going about the x-axis. So the x-axis, so about here, disk washer. So horizontal axis of revolution, let's go with the disk washer. So we're going to find the area of circles again. We're going to make circles. In terms of x, we're going from 1 to 4. And then draw radii in here. The radius is just 1 over x squared. Right? And then we square that. So if I square 1 over x squared, I get 1 over x to the 4th. So it's going to be pi times integral from 1 to 4 of 1 over x to the 4th, which I'll think of x to the negative 4. So I integrate that, I get x to the negative 3 over negative 3. So negative 1 over 3x cubed. And I do it from 1 to 4. So let's see, let's move this down just a little bit. So we got room here. We got pi times, plug 4 in there. 4 cubed is 64. Times 3 is 192. We get negative 1 over 192. Then minus, plug 1 in there, we get 1 over 3. Negative 1 over 3. All right, so 2 negatives are going to make a positive. This is 64 over 192. Minus 1 over 192 would be 63 over 192. So we get 63 pi over 192. And then, let's see, 10, 12. 3 goes in 192 64 times. 3 goes in 63 21 times. So 21 pi over 64. There would be our volume if we did it about the x-axis. Now we're going to do it about the y-axis. Okay, so the y-axis is a vertical axis. So first thing I'm thinking to myself, I'm going about a y-axis. Could I do this with the shell method? Make it stuff easier on myself. So everything's already in terms of x. And the answer is yes. I'll do 2 pi, because now we're working with the circumference of circles, times the integral from 1 to 4. And then we're going about the y-axis, so any point in this region, the distance from that point to the y-axis is x. And then again, the if we draw lines in here, the radii, or those wouldn't be the radii, they'd be the height of their cylinders, are going to be 1 over x squared. So this turns out to be 2 pi times the integral from 1 to 4 of 1 over x. Why did I write the 1 out of 4 so far away? It's going to be 1 over x with respect to x, which turns out to be the natural log of the absolute value of x. We do it from 1 to 4. And if I didn't do the absolute value, it's no big deal because anything from 1 to 4 is positive. Right? So let's see, plug in 4, and we get natural log of 4, minus plug in 1, we get natural log of 1. So we get 2 pi times the natural log of 4. Now, there's nothing wrong with that answer. All right, that's a fine answer. We could use the calculator to get a decimal approximation, but exact answers are always nicer. Now, if you were taking a multiple choice test, it's possible that they would break that down a bit and break down the natural log of 4. So you'd still have the 2 pi here, but maybe they'd make the natural log of 4 natural log of 2 squared. Then they'd bring the 2 in front, and 2 times 2 pi would be 4 pi, natural log of 2. Right? That's the same thing. If you were doing this and you checked your answer in the back of a math book, this is how they'd write the answer. Okay, so just be prepared for that. All right, now last here we were going to do it about the line x equals 4. You know what, this bugs me too. Why does this put these lines on me? All right, so we're going to revolve it about the line x equals 4. So for our last thing here, all about the line x equals 4. So x equals 4 would be this line right here. All right, so this is good. This is something different that we haven't done yet. All right, so line x equals 4 is a vertical line. So I like the shell method for vertical axis of revolutions. So I'm going to go with the shell method. So it's going to be 2 pi times integral. In terms of x, we're going 1 to 4. Now it's a little different. If I pick points in here, it's no longer just x to the axis of revolution. But I could stop and think for a second. What if I picked a point right on this line? How far is this point from the axis of revolution? Well, it's 4 minus 1, it's 3. Right? Matter of fact, any point in here that I pick, the distance from that point to x equals 4 is just going to be 4 minus x. It's always going to be the x on the right minus the x on the left. So 4 minus x. If this x right here was at 2, the distance from 2 to 4 is 2. If this one was at 3, the distance is 1. It's always 4 minus that. Okay. And then the height of the region is going to remain the same. It's going to be 1 over x squared. We'll integrate that with respect to x. So we've got 2 pi times the integral from 1 to 4. If I multiply this out, I'm going to get 4 over x squared, which I'll rewrite as 4x to the negative 2. Then minus x over x squared, which would be 1 over x. And I don't rewrite this one as x to the negative 1 because I can't use the power rule on x to the negative 1. I can use the power rule on 4x to the negative 2 to integrate it. I just add 1 to the exponent, get negative 1, divide by negative 1. So I'll get 4x to the negative 1 over negative 1, which would be negative 4 over x. And then minus the antiderivative of 1 over x is the natural log of the absolute value of x. But since we're going from 1 to 4, x's are positive, so I'll just say the natural log of x. And we do it from 1 to 4. So now plug 4 in there. We get 2 pi times negative 4 over 4 would be negative 1 minus the natural log of 4. And minus, put 1 in there, get negative 4 over 1 is negative 4 minus the natural log of 1. So we've got 2 pi. These two negatives make that a positive 4. Minus 1 would be 3. Minus natural log of 4. And the natural log of 1 is 0. So we just get 2 pi times 3 minus the natural log of 4. Which again, they may, if you're taking a multiple choice test or you're looking at answers in the back of the book, they'll probably break this natural log of 4 down to natural log of 2 squared, and they'll make it 2 natural log of 2. Okay, back in the old days, we had to look natural logs up in the back of a book, so they tried to just make sure they had the natural log of prime numbers. And then you could find anything by using those. It made for less you had to put in the back of the book. Nowadays, your calculator can do that, so it's sort of an outdated skill. So there's nothing wrong with leaving the answer like this. So, you guys, we've gone over the shell method here. Shell method is a great thing to use if you got to go about a vertical axis of revolution. Right? Something like this. We went about the x-axis, it's horizontal, stick with the disk washer. Unless they give you everything x in terms of y, then do the shell method, because if it's horizontal, you want everything in terms of y. So if you're already given the function in terms of y, you're doing about a horizontal axis of revolution, the shell method is the one I'd use. If everything's in terms of y, you're doing about a vertical axis of revolution, stick with the disk washer. Now with the shell, vertical axis of revolutions in terms of x. So if you got to do something about a vertical line, like part 2 here, we did about the y-axis, a vertical line, everything we were given was in terms of x, use the shell method. Okay, here, first one, everything was given in terms of x, we went about a horizontal axis, stuck with the disk washer. The next 2 examples were vertical axis of revolution, so we went with the shell. Okay, it makes it easier, it helps you out. Okay, guys, as with anything, this is new. You got to practice it, you got to work at it. Okay, just keep working hard, keep practicing, and don't ever forget to endeavor to persevere.